Here is a speed time graph for a train journey between two stations. The journey took 100 seconds. Calculate the time taken by the train to travel half the distance between the two stations, and then compare the acceleration of the train during the first part of its journey with the acceleration during the last part of the journey. So I think we need to do a few things here before we get to the time taken. That is, we need to find the distance. So we need to find the total distance, and then we have to find half distance or half that distance, and then we get the time taken. So to find the distance in the speed time graph, so distance is given by the area under the curve. So the distance in this case would be the area of the trapezium. So I'm going to write the distance area of the trapezium and that would be half times sum of the parallel sides. So this is 100 units and this is, so that would be 30, and of course this is 80. So then we'd have 80 minus 30, so that is 50 units. And the perpendicular height, so this is the height, that would be just 10, 11, 12. So it's half times the sum of the parallel sides, so 100 plus 50 multiplied by 12. So that's 6, so that is 150 multiplied by 6, that is 900 meters. So we now know the total distance. So the total distance is 900 meters, and we know half distance. Obviously it is 450 meters. So we need to find how much time it would take to travel 450 meters. So I would say we need to find time taken to travel 450 meters. So in the first part, that is this part, you see the speed is changing, there is acceleration. So to find the time, we can, I think what I would do is find the area of this triangle to find the distance, and we know the time already, that's in 30 seconds. So then see what we get is area of the triangle. So we can say, or we can say distance traveled in 30 seconds. Distance traveled in 30 seconds, and we would get half times base, which is 30, times the height, which is 12, so that is 180 meters. So we keep this because it is 30 seconds time taken to travel 180 meters. So we need to find for 450 meters. So we do 450 minus 180, and that is 0 and 7 and 2. Okay, 270 meters. See now here from after, after 30 seconds, from 30 to 80 seconds, the speed is constant. So if it's a constant speed, we'll apply the formula. So we know that speed is equal to distance divided by time. So we hope that within the 270 meter, and we think it has not gone beyond the 80 second, if the time is beyond the 80 second, again there's deceleration, so we need to take care of that. But that's not going to happen because that's what they're asking, half the distance. So s is distance divided by time, so therefore s, we know the speed is 12. So 12 is distance, which we also know 270 divided by time. So we get time is 270 divided by 12. So that is equal to 22.5 seconds. So the total time, so the answer to part A finally, total time for half distance, which is 450 meters, equals, so that is 30 plus 22.5, that is 52.5 seconds, and that's the answer. Okay, so 52.5 seconds. So we got our first answer, so we will get some marks here, probably all the marks. Okay, so next we got to compare the acceleration of the train during the first part with the acceleration on the second part. So obviously first thing to note is this is acceleration, so it's and this is deceleration. So speed is increasing, speed is decreasing, deceleration. Now we could find exactly by how much it is accelerating and by what it is decelerating, so we can do all that. So what we can do is acceleration here for the first 30 seconds. So acceleration would be v minus u divided by t. So the final speed, the final velocity, it is 12 minus 0 divided by the time, that is 30, and 0.4 meter per second square. And then we can find what deceleration is. The deceleration would be, the final velocity is 0, so it's 0 minus 12 out of 20, because this is in 20 seconds. So 20, so 12 divided by 20 is 0.6, and that is minus 0.6, so minus 0.6 meter per second squares. That's deceleration. So you see it is decelerating faster than it was accelerating. So we can write that. So we can say that decelerating faster than accelerating. And that's it really, that completes the question. Thank you so much for viewing, and if you like the video, please subscribe. Thank you.